Yeah, continuing from the previous session, let's brush up about this concept on data abstraction. Abstraction itself, the word means that you are trying to hide some background details and highlight only the essential details. Okay, so you are going to specify or you are going to present only the important details about the object and hiding away all the unnecessary background details and the details about the implementation of that particular method or that particular purpose or the particular function. Okay, so it is the way or art of managing complexity in your object oriented programming. Okay, data abstraction is basically to represent only the essential, very important features of that particular object and hiding away all the unnecessary details about the object. Okay, that is what you mean by data abstraction. Then the basic pillars of object-oriented programming, you can see the encapsulation, inheritance, and polymorphism. Okay, these are the basic pillars of object-oriented programming. First, let us explore what is meant by encapsulation. So, as we have earlier seen that a class is a composition of data and methods. Okay, an object contains of data attributes, that means it exhibits certain characteristics, and there are certain methods also associated with an object. So combining them together, you get a class, and encapsulation is an art of wrapping up both of these two together into one entity or one unit, which is called as an object. Okay, so the way in which you access this data is through methods. So you can see the block diagram, which clearly tells you about the way data is managed or visible to the outside world. So data is totally hidden from the outside world, and only through methods you will be communicating, or basically you will be computing certain computations over the data. You will be displaying this data, you will be inputting data. All these activities are done through methods. So methods are basically the interfacing units. Getting my point? So methods are basically trying to interact with the outside world. Okay. So you can see it in an encapsulated form, the way in which a capsule is there. You can see a physical representation of working class with some example. So you can see an example for an encapsulation where there is a class called as box, and this class has three private attributes: length, width, and height. And you can see the specification of a class, data items plus methods. So methods are two methods. First is area, the other one is volume. Okay, so these methods are basically computing the area and the length, width, and height of a particular object called as box, and you will be using, I mean, the internal details about what is the formula for area, how are you computing in Java, etc. are hidden. So what is visible to the outside world? Only the essential details. Like there is an object, three attributes, two methods. That's all. So now you have got this point of what is data, how it is shielded by these methods. So here in encapsulation, just like you can see the physical capsules in pharmacy, they are sometimes totally visible, sometimes semi-visible, sometimes fully transparent, and sometimes fully opaque, right? Fully opaque. Opaque in the sense completely they are not visible to the outside world. These are the various forms, in fact, to show you encapsulation. There are two rules which guide you to provide encapsulation to your object. When you place the data, you have to place the related operations in that particular class. You cannot write unnecessary methods in that particular class. So only the related methods of a particular class need to be included into that class. and use responsibility driven design to determine the grouping of data and operations into these classes. Okay. So these are the rules for information hiding. You can see rule number 1, where you don't expose data items at all. Then you don't expose the difference between stored data and derived data. And rule 3 is don't ever expose the class internal structure. And obviously the fourth one is you don't expose the implementation details of the class as well. Okay. So that is the concept of data encapsulation. Now, the third pillar of information hiding, or the third pillar of object-oriented programming, is inheritance. Okay, so let's see about inheritance now. It is the way of hierarchically arranging the classes. That means, as I have earlier exhibited, that two or more objects can share information between each other, right? So whenever you are sharing information between each other, you might come across some similarities between objects. Like certain characteristic features are being shared commonly between two or more objects. Then similarly, you also have certain characteristic features being exponentially growing from other classes, right? You are extending from other classes. So such characteristic features you are identifying and then arranging these classes to form a hierarchy. Okay, so that's nothing but inheritance. One valid example I would like to quote in this regard is how you can have your dogs, a small example, how you can arrange these dogs based on their characteristic features. Okay, so basically the four-legged animals, which are nothing but quadruped animals, I would like to classify them into two categories. First category is canine family, in which there are some wolves and there are some dogs, okay, based on certain characteristic feature. Then similarly from dogs, I have some breeds based on the characteristic feature of the breed. I will now classify them into Coolie and Retriever. Then similarly, these retrievers can further be classified as a Golden Retriever and a Labrador Retriever. And when it comes to Coolie, that is breeds, there are some rough Coolie, smooth Coolie, border Coolie, bearded Coolie, like that there are some classes. Okay, when it comes to wolf, there is something called as Siberian wolf. Okay, so like this they are trying to have various classes. Okay, so inheritance is the process of reusing classes, reusing some information which can commonly be shared, sometimes differentially shared between classes. Okay, so it is the way in which you extend the functionalities of a certain class called as base class and the form of a derived class. So process by which one object acquires properties of other classes. Okay, so now in this process, I can now call these two classes as the first class from where I derive the basic functionalities is called as a superclass or a base class or a parent class. Child class, whatever is acquiring or extending the properties of this superclass, is always called as either subclass, derived class, or child class. Okay, so that is how you have your inheritance, and these are the various forms of inheritance. Suppose if you are having only single base class and a single child class, it is single inheritance. And if you are having a multi-level inheritance, you can see that there is a hierarchy of classes, three levels. Okay, A is a superclass, B is a subclass, and C is a sub-subclass, just like you have a grandchild. Okay, grandparent, parent, and child. Okay, or parent, child, and grandchild. So any of the terminology you can use. Similarly, you can also see hierarchical inheritance where there is a single parent and there are multiple children sharing from a common base. Okay. So that's about hierarchical. There is multiple inheritance which is completely not supported by Java, like multiple parents giving rise to a common child. So it's not possible in multiple inheritance is not possible in Java.